sir. It's a privilege to introduce Dr. Hasan Rangwala. Dr. Hasan Rangwala is an assistant professor at Civil Engineering Department since 2015. He obtained BE degree in Civil Engineering from LD College of Engineering, Ahmedabad in 2008 and MTech degree in Earthquake Engineering with specialization in soil dynamics from IIT Roorkee in 2010. He completed his doctoral research and obtained PhD degree in 2014 from IIT Roorkee. His doctoral research area was earthquake resistant design of foundations. He has academic experience of 1.5 years at Manit, Bhopal prior to joining at Nirma University. Dr. Rangwala has 2 book chapters, 4 international journal papers and 6 international conference papers to his credit. He is actively involved in supervising major projects of MTech as well as various students' projects at both undergraduate and postgraduate level. Dr. Rangwala is awarded with a research project funded by Nirma University. He is actively involved in testing and consultancy work related to foundation design. He is also involved in environmental audit work carried out by the department. He is teaching subjects like geology and geotechnical engineering, foundation engineering, reinforced earth and geosynthetics, sustainable building technologies at undergraduate level and foundation engineering at postgraduate level. His areas of research include analysis and design of foundations and retaining structures, dynamic properties of soil and reinforced earth. It's a privilege to have you on this occasion, sir. I request our resource person, Dr. Hasan Rangwala, to take over. Yes, sir, you are audible. You can continue. Thank you, sir. Thank you, sir.
Sir, yet to sir.
Yes, sir. Yeah. Yes, sir, it is visible. You can continue, sir. Yeah.
Together as in the field. Okay. Now, what is the content of this is basically say what are the different ground improvement methods that is being used in the system currently or in the practice currently, and then we will be seeing some of the research work done at near my university. So that is what our plan for the session. Uh, okay. Uh, the ground improvement technique, I hope most of the participants belong to the civil engineering field itself, and mostly you must have came across this term, that is the ground improvement techniques or ground improvement technologies, which are nothing but some geotechnical construction methods which can be either altering or maybe improving the poor ground. Okay, so say in any case, if I have some technique or say some of the soil which is poor, what I have to do is I have only two options. One is the soil replacement, and the another is to alter the properties of the ground, or in other words, I will say improve the properties of ground. So any improvement method or any method that will improve the property of ground, that is called as ground improvement method in general. Okay, what we need to take care in this is surely the feasibility in terms of maybe monitoring feasibility, that is the economy, the environment, and all the technical reasons. Okay, that means if I need a specific uh, strength of any soil or specific properties of the soil, okay, that I should achieve, but not at some cost of economy or environment. Okay, so all the three things I have to go with hand in hand. Okay, uh, why we do or why we get to the ground improvement technique. I hope this is quite generic. Just you almost most of the people would be aware that our infrastructure, our industry is growing rapidly in urban area, in all the mega and metro cities. You must have seen this in your neighborhood, okay, in any of the cities in India currently. So what we have is we have scarcity of useful land, as well as we have scarcity of the material, good material. Okay, so if I can save any material in any way, I should go for. Okay, uh, the demand for land reclamation is also quite higher. We are reclaiming quite number of land in most of the cities, or quite large area of the land of in cities. Why? Because in the to avoid this scarcity or for the answering the rapid infrastructure development, either I have to go with the higher high-rise buildings, or I have to reclaim some land, poor land, which can be improved and can be used for various construction purposes. Okay. Here surely whenever I'm seeing construction purposes, it may include buildings, it may include any infrastructure or any structure within this engineering domain. Right. Technically, what are the problems is you may have poor shear strength, you may have high compressibility, you may have different settings. Okay, so these are the three problems that I've taken technically as far as the geotechnical problems are concerned. So if I can address my shear strength, if I can address my settlement, if I can address the compressibility, then I can surely address the or I can only give a proper ground improvement method for the given project. Okay. Now we move further with how and what we do. Okay, these are some of the basic questions that you have to always ask whenever we start with any of the methods. Okay, so what we generally do is we just improve the bearing capacity and we improve the settlement uh, behavior. That is, we reduce settlement to a considerable extent. What do you mean by considerable extent? Is to reduce the settlement within the limit that has been prescribed in the either the IS code or maybe in the project document. Okay. Now, for getting this bearing capacity increase or maybe reducing the settlement, what we generally do is we use different engineering techniques from simple like removal and replacement of the soil, okay, which was quite early technique. Now, if we see removal and replacement is quite non-economical technique, so we tend to move to various other techniques like pre-compression, vertical drains, in-situ densification, when we go in the field itself, grouting, stabilization, all of these are some or other chemical or say cementitious admixing. Okay, and the method that we are going to use for today is the uh, soil reinforcement system. Okay, uh, so how we are going to do is we can do uh, so we can do this ground improvement with various methods or various techniques. Okay, but largely it is divided in these three categories. That is mechanical stabilization, chemical stabilization, and geosynthetics or reinforcing element. Okay, what is mechanical stabilization? Is basically to improve the properties by compaction. Okay, by compacting the soil, or maybe increasing the friction angle of the soil within uh, the internal friction angle of the soil. Okay, and what is the chemical stabilization? Is you add some chemicals and you stabilize the properties of say your uh, soil, okay, with the various types of admixtures. Okay, what are these admixtures? Start from maybe lime or cement to fly ash to various types of chemicals. Okay, so whatever chemical functions in a good way and non-polluting, surely you can put that in the chemical stabilization. Okay, and the last is the use of reinforcing element. Okay, is nothing but to introduce some of the reinforcing material. What is this reinforcing material? Is nothing but they are adding some tensile capacity into the ground. Okay, what is this tensile capacity? Is say I have when I take the soil, what I have is my basic capacity is the shear strength. Okay, when I get away with the shear strength and I see that okay, I do not have or I have less shear strength, what I have to do is I have to improve. But how can I improve it? I will be adding some other element like this reinforcing element, which is having good tension capacity. And what I will have is I may have because of this taking element, I may have improvement in the ground, okay, which can improve either the uh, cohesion in the soil or maybe even of internal friction. I hope I'm audible. Hello? Okay, fine. And screens are also visible because
Yes, sir. You are audible, sir. Continue.
okay, good. Thank you. Thank you. So where is the application of the ground improvement is you have retaining structures, you may have industrial or mining sector, you may have bridges, waterways, civilization of slope, railway, and what is today's topic is on highways or say pavement. Okay, so basically, whenever we take any civil engineering structure, we get to have low, say, strength soil. We can use this ground improvement method. For today's discussion, probably we have the highways and road construction are of utmost importance for the session. Okay, so with that, we will go to the today's session. Okay, so what this particular session we will be focusing upon is the ground improvement method using soil reinforcement that we have discussed. Okay, then soil reinforcement technique. What are these soil reinforcement techniques? And we will be say showing some of the research work which has been done at the nearby university. Okay, uh, so we will just take a look at first the reinforced soil and reinforced soil system. What are the different types of reinforced soil systems that has been there in the practice? So what is this reinforced soil? Is reinforced soil is most commonly used ground management method in the current time, and there has been quite good hope of this method. Why? Because most of the material which has been used is quite local, except if you see some for most of the applications, if you see the local material, you have any of the material you can put inside the soil, checking surely the strength, characteristics, and behavior, and you can look upon various different locally available materials. Okay. What this technique do is the technique is doing soil strength improvement by adding some reinforcing elements. Okay. What are these reinforcing elements? Maybe a synthetic fiber, maybe a natural fiber, maybe I may have even tension taking elements like I may have some steel. Okay, but generally some synthetic fibers or natural fibers are used. Okay, so what it will be taking is will be a addition of this tension resisting element in association to the frictional soil. Okay, and it will become a reinforced soil. Okay, this can be also termed as reinforced earth because the soil is some of the researchers termed it as reinforced earth. Okay, now one of the basic things that you have to see is you have to have a friction in the soil for using this type of particular reinforcement. Okay, in case when you are having low frictional soil or a cohesive soil for the case, it is related with highly more of the compressibility, where it is suggested to use drains rather than the reinforcing, because the basic problem with cohesive soil would be there as of the say water problem or the water loss within the soil. Okay, so we will be just taking a glimpse to the history from where this reinforced soil comes. Is coming till 1966. So it is the concept of more than 50 years now. Okay, one of the French engineer Henri Vidal uh, termed this particular thing as reinforced earth, and he has employed simple concept of the synthetic fiber along with the reinforced that is being used as reinforcements, and he has got a reinforced soil system in a mechanical way in a RE wall that is called as reinforced earth wall, and it has been successful and economical because in those times they had basically quite number of synthetic or say synthetic clothes are available, and that became an economical aspect also. So that is where it all started, and uh, now we go to uh, what is this reinforcement technique, or you can say types of reinforced soil. Okay, so there can be two types of systems. One is systematically arranged or oriented system, which is called, and another is randomly distributed fiber reinforced soil system. Okay, what is the basic difference between these two? Is an orientally distributed fiber or systematically distributed fiber. You have layers of soil and reinforcements, while in the randomly distributed fibers, you have just put some fibers mixed with the soil strata, and here you can see some fibers within the system, while in this particular system, you can see this is a reinforcement layer, okay, with which maybe here it is shown as a grid. Okay, you can see various types of reinforcements, geosynthetics available in the form of strips to grid to net to mat. Okay, and which can be arranged in a systematic manner. Okay, between the soil layers. While in this particular system, what we do is we just mix the soil and the fiber reinforcement, okay, or the reinforcement in forms of fiber, and we put the soil in place. Okay, so what we have to do in this layered system of systematically reinforced system is, as discussed, you just put the reinforcement and you go with the layers. Okay, so how this is useful is probably whenever you have uh, some uh, the retaining wall may be made, okay, and it has to be put on, say, for example, here it is being shown for a railway track. So, if I have to make some another railway track and I have to make the extension, then what I would have is, because of this, I would be going for a steep slope, or I may have to go for a vertical slope. Say, I may have to go for a vertical wall. In that case, what I require is this soil is to be strengthened, and this improved soil should be requiring the some element which has to be added. Okay, this is called as reinforcement. Okay, now we go to some of the applications of this. Is therefore this is one of the application of reinforced earth wall. So here if you see this wall, okay, I have to go with the complete concrete wall. Okay, while in comparison to this, here I have got some layers of soil and reinforcement on the right side. Okay, with some pressing panels. So what is the benefit on this part is you have reduced uh, concrete, a number of concrete, the volume of concrete, and you have used mostly the local material, field material, as well as this will also require less time. Why? Because what you have to do is here, if you see with the construction process, you have to go with the layered construction and you have to wait until a particular time. Okay, while in this you don't have to wait for anything. You just lay the particular reinforcement, you lay the soil, you again lay the another reinforcement layer, and so on and so far. Okay, so speedy system is there. You can have say your concrete is saved, your local material is available, and your environment is also saved. How environment is also saved is this is all concrete. Okay, so what you can do is you can also put some vegetation, and this, if it is in slope, okay, that slope would be also say for example in the last slide it has been seen, shown that vegetation can be there and naturally it will be also stabilized. Okay, so this is about the systematically reinforced system. What are the different types of reinforcement used in this is, say you have your textiles, your membrane, your grade, and your composite. There are different applications. Your textiles and your grade would solely increase the strength. Your membrane will always be used when you want to increase permeability or you want to add some water passage into the soil. Okay. Different application may need different types of geosynthetics, which right now we are not going to go in this details of what the reinforcements are used for what different applications. And your composites are the reinforcement which is mix of any of the two of your textile and your grid, or maybe your membrane and your grid. So as per the application, if I have to combine two or more geosynthetic, then it is your composite. Similarly, I can use natural fibers also, uh, which nowadays in India has been quite prevalent. You must have heard in various new means media also that uh, the new of the new there are new projects coming up with the natural fibers. Simple. Uh, you must have seen the coir fibers or the coir green. Okay, in various applications, that grid has to be placed simply into the soil, as we have done in the geosynthetics, okay, where you have done the reinforcement system of the soil and geosynthetic material, or rather, it is the synthetic material. This is purely the natural material. So you have one more added advantage being the say natural material, or the say it is a non-polluting material. Okay. Uh, then we come to the randomly distributed fiber system. If the reinforcement technique system, we have started with the systematically reinforced the randomly distributed fiber reinforced coil system. And hello, I hope I'm hello. Yeah, Mr. Rudresh, am I Mr. Rudresh?
Yes, sir, you're audible. Please continue.
Okay. Thank you, ma'am. Okay. The randomly distributed fibers are in form of the fiber which is mixed with the soil. Okay. So what we do in this is simply say, for example, I have got the simple example is the coir. Okay, you must have used, you must have seen the coir waste. Okay, that coir waste, if I will be having that mixed with the soil, okay, then also my soil can be improved, and this improved soil can be used for various preliminary. Okay, so what are the properties that I have to see is probably the raw material. Say in the case I observed is say for coir, then the raw material I have to see. I have to also see the type of soil. Okay, for which I'm doing the ground improvement. So uh, if I have different types of soil, maybe I for a sand I have used the coir fiber. In the other case, if there is a silty sand, I may not be able to use the uh, same coir fiber. Okay, because of the behavior of the soil reinforcement system. Okay, similarly, the denier, which is the uh, form of the density of the fiber. So it is basically the weight of unit length of the fiber, the length of fiber available in the market, okay, and aspect ratio, that is the diameter to length ratio for a given set of say fiber. Okay, so for different fibers, I have to see these properties, and solely based on this and based on some studies, I have to make a recommendation that what is the percentage of the fiber that I want to use in a particular application. Okay, so what is the percentage of the fibers that I have to use is for say 100% of unreinforcement system, how much percentage of fiber by weight you will require. Okay, so what are the fibers used in the practice are synthetic fiber, neutral fiber. For natural, I may have coir or the coconut fiber, I may have rice husk, I may have jute fiber, I may have sugarcane fiber, um, and also I may have synthetic fibers. Okay. If we see the current practices in most of part, we are now going towards the natural fiber. Why? Because one is it is easily available, another is it is economic. Yeah. So if I have got an economic option which is locally available, which is quite good technically also, then probably I should use for natural fibers rather than synthetic fiber, which is say polypropylene and polyvinyl, which is also adding into the pollution. Okay. So now we will see some of the research work that is being done at our institute. So I have included here two of my research uh, done by some of the BTech students. Okay. Now one is randomly distributed fiber with the jute fiber, and another with the sugarcane fiber. For both, the CBR tests have been done, and we have tried to find values of CBR and also tried for design of soil subgrade system. Okay, so for both, what is the basic application is either I can use it for soil subgrade, or I can use it for the say the road itself or the pavement itself. Okay. Now, what is the if first So we will now go with the two of this uh, research work. So first is effect of randomly distributed jute fiber uh, on the design of subgrade soil or soil subgrade. In this particular paper, which has been published in CBR as a chapter, is uh, the jute fiber reinforcement. The idea of techniques have been used, and we have attempted to make some experimental evaluation, and we have also attempted for the design of subgrade with unreinforced and reinforced conditions to compare the addition of reinforcement and addition of strength because of the reinforcement. Okay. So introducing the basic uh, aspect of this study is um, we are using the natural fiber. Why we are using natural fiber? The reasons have been discussed, and more of the focus could have been two. One is in the rural area, is you have road pavements are made up of soil itself. Okay, and if you go with the urban areas, your subgrades are soil soil layer. So in the both cases, what you have is if I would be having a simple soil pavement made up of just simple soils or available. Okay, in the rural road pavement. Okay, instead of that, if I can improve these conditions, then I can have some fiber, which is natural fiber available in the vicinity. Then you can surely improve the life of this pavement. And second is you can reduce the thickness of subgrade if used in the um, urban areas. Also, we can stabilize, if you see here in the down, top down, sorry, bottom down image, what you have is uh, you have some non-stabilized pavement. If we have got some reinforcement, this unstabilized condition would not have, we will not have got that kind of condition. Yeah. Now, in this study, we have used jute fiber. So, jute fiber is widely used in textile industries to make clothes, maybe carpet, baking fabric, and various other uh, it- uh, for various other applications. What are these? Typically, it is coming from this phosphorus plant. Okay, and plenty available in India, Bangladesh, and China. Okay, so for this particular research, we have used geo fiber. It is also called as geojute. Okay, these are some of the engineering properties of this fiber. That is, it was 2.5 mm of diameter and uh, say 12.5 mm length. Okay, with the linear of 1.9 to 2.2. Okay. The experimental study is basically consisting of uh, some of the soil collection and soil collection mixing of fiber, some of the test. I hope mostly we will not go with the test procedure, but some test parameters, number of tests that would have been required, and effect of this parameter. Okay. So first and foremost is the raw material. So silty soil was silty sand was procured from the university campus itself, and this is the soil fiber mix. So what has been done is these are the basic fibers which has been taken. Out of this, all the fibers have been splitted in small fabric, and it has been mixed with the soil in the dried form, and then it has been used for further study. Okay, so this is the raw material that has been procured in form of soil as well as the uh, fiber, then or rather the thread. Okay, then the fibers has been there. So we have splitted all the rope in the form of fibers and mix it with the dry soil, and surely then we have done standard Proctor test. So we have added some water and then the compaction. Okay. Now, what is one of the major part is the number or the content of the fiber is that has been 0 to 0.8 percentage and into the interval of 0.2. So we have taken the soil fiber mix where I have 100% of soil and 0% of fiber. You may have 99.8% of soil and 0.2% of fiber, and so on and so far up to 99.2% of soil and 0.8% of fiber. Usually, if we see 0.8 percentage is quite lesser, or it seems to be lesser. Okay, but what happens is when you go with the density of soil and density of this fiber, okay, for 1% of fiber even you have got quite higher volume. So that is why we have stick up to 0.8, which is surely also available in quite number of literatures. So from that also we have restricted ourselves to 0.8. Then we did some standard Proctor test. We got the OMC and MDD, and for each of the fiber percentage at the OMC and MDD, we have prepared the test sample for California bearing ratio or CBR, and based on this CBR, we designed the pavement according to the IRC 372,012. For this is the table from IRC 37. Okay, so what are the different results and discussion is for the results we have received at the end of this study is we have seen that optimum moisture content is increasing with the fiber content. So why that has been there is because we have added the water into the soil, and the jute fiber also consumes the water. So that may be a primary reason to have additional OMC, as well as the soil fiber mix is quite dense. So if we see any denser material is always having the higher OMC. But MDD or say the dye density also decreases. Okay, and it has been seen that at 0.6% of fiber content, it has been saturated. Okay, here we have done the CBR test, and in the CBR test we have seen that constantly the CBR increases from 0 to 0.8 percentage of fiber content. If you see here, the average increase of the 7.5 to 11 is almost 1.5 times to the base value of 104 soil. Okay, so we can increase quite higher or to say CBR to quite higher extent. Okay. Then we perform the uh, design of the pavement or rather the design of subgrade. Okay. And we have seen that for various percentage of fibers or different chemistries, we have got the thickness of the pavement ready. Okay. What is the benefit of this reduction? Is solely we save the material. Okay, because if we see the soil which has been used in this pavement subgrade is nothing but it is always agricultural soil, sometimes from very nearby area, or it may be have you may have to borrow from some other land. So if I can reduce this, say for example, in one of the conditions, say from 600 up to say 550 or say 540, and I can use that 50 or 50 for a large stretch of road, then I will be actually saving quite higher volume of the soil. Okay, so that is the primary conclusion, okay, of the particular research, that we can reduce the pavement say uh, thickness uh, uh, by quite a number, and we can increase the CBR. CBR is the basic parameter that is been affecting the design of pavement or the design of subgrades for the thing. Uh, then we go to the other study. This is primarily a work which has been covered or which has been carried out by the BTech students. Uh, what has been done in this particular study is sugarcane fibers have been used with again RDFS technique, that is randomly distributed fiber reinforcement system, and we have done we have modified Proctor test, and based on that again we have conducted the CBI test. Okay. So what is firstly this technique and what we have adopted during this particular research? You could see this is basically the sugarcane waste. You must have to treat this waste as any say sugarcane juice shop. Okay. So what we get is say from sugarcane, we get this sugarcane salt. Okay, and usually what is done in the research studies that we have taken in literature is they burn this and they get some powder, sugarcane powder, is called also called as bagashi ash, and then they improve the ground using this bagashi ash. But what we have done is instead of having this burning, we have uh, used this top sugarcane fiber in and we have just cut this particular fiber. You can see these fibers are quite long. So we have cut the samples to 2 to 3 centimeters. Okay, and we have directly put it into the soil, and we try to find whether we could increase the strength of the soil. Again, we have taken 0 to 0.8 percentage of fiber in the interval of 0.2, and we have got the modified Proctor test and also soap CBR. Here also we have done the soap CBR. We have done the Proctor test with, so these are some basic details about the Proctor test that is being used. Okay, so what what is the difference between the modified Proctor test and standard Proctor test is one is surely the mold size, where we use the larger mold. In the standard Proctor test, we use 12.5 mm, sorry, 12.5 centimeter or 125 mm thickness of the sample, or 125 mm height and 100 mm diameter, while in the modified Proctor we use 150 mm diameter and 175 mm height, and some of the hammer weight and drop of the hammer is also increasing. Here is 4.5 by 2.6 kg hammer has been used in standard Proctor that has been procured in the last research that we have studied. And here it has been 5 layers, while 3 layers only is done in the say modified Proctor, or in the standard Proctor test. Okay. Next is unsoaked and soaked CBR. So I hope most of you are aware of how the soaked CBR and unsoaked CBR is done. So what we do is just put the sample and we add um, uh, we do the increase the penetration by having this screw jack assembly, and we record the load at particular penetration. Okay, and after doing that, we make the analysis of CBR value. Okay, similarly, in the soap CBR, what we do is we put the soil in water of saturated condition for next 6 hours, that is 4 days, and we test it again for the say soil. So what is difference between soap CBR and soap CBR is surely it will be giving the better idea for the CBR strength of fully saturated soil. In this, we have done say 10 CBR test for the soil, okay, which is again a non-plastic soil, okay, taken from the university campus itself. This is the Sieve Analysis of the sample, and these are some of the modified Proctor test results. So if you see these two, what we can see is with increase of the fiber, we have increase in the MDD, while OMC is quite, you can say, similar for both 0.2 and 0.6% of fiber. But if I'll go with, say, 0.8% fiber, my OMC as well as MDD is quite different behavior. If you see here, we have 0, 0.2, 0.4, 0.6, and 0.8 as the fibers. If you see the OMC is increasing quite linearly, but in the MDD, if you see 0.6, we have some increase, and after that we have got some decrease in the MDD. Okay, why would I have this type of particular behavior? Could have been because of the size of the particles. Okay, so what you have is up to 0.6. I could have got the my soil structure of the soil reinforcement system is settled well, while the increase of fiber would not be enhancing my density. Okay, so what could I do for this particular thing is only if I will be using some less length of the sample. In this case, what we have taken in this particular study as 25 mm, okay, for 0.8 percentage of fiber, if I could have used say 2 centimeter, say 20 fiber, then surely I would have some increase in the MPD. Okay, because percentage of, as we already discussed, my percentage of fiber, my length of fiber, my linear of fiber are always some of the factors that will affect all my crops. Okay. Then we have surely done the CBR test, which is the basic graph, and you can see the CBR values on scope and scope CBR various content. Uh, and you can see that soap CBR is almost half to the soap CBR. So what you should normally use is you should use soap CBR if the water table is higher, or in case of pavement, also we use the soap CBR because it is always going to be affected by the rain. Okay. Some of the concluding remarks, especially not written, is I rather open the session, or I would wish to open the session for the questions, and then we can have some concluding remarks at the end. So I think I will hand over the session to again Dr. Rudresh. Dr. Rudresh?
Thank you, sir.
Okay.
Thank you so much for your wonderful presentation, for your time, experience, and knowledgeful words. We thank you for your time. Thank you so much. I request the participants, the attendees, if you have any queries, you can raise your hand. Please raise your hand if you have any queries. I request Manjula Devi to ask your query, please.
Hello.
Hello, I'm audible. Actually I was unmuted, so now I'm
you're
Sir,
audible, ma'am. You can ask now.
Okay. May I know the minimum CBR requirements for subgrade?
It depends on firstly your application pattern. For that you should
Hello.
hello. I guess okay. So I think you should go for this only the IR 37. Okay, and for minimum traffic, what is your traffic depends on that. Your CBR value would be affecting. So I guess we should refer to IS 37 for that.
Okay. No, they have written if it is less than 20 MSA and beyond that thing. So that's what actually I did one work on this. I used with marine clay along with the marble dust and marine clay along with the quarry dust. Okay, in that time, so that I was expected, my expectation was maybe marble dust consists of more calcium oxide. It will give more CBR value. That was my expectation before that work, but I got CBR value high for the stone dust. But that I used both the case. I used that sand content is more. My Sieve Analysis, everything is same, but I got quarry dust gave me a more CBR value.
Okay. Now, the question is why the query dust would have got the CBR value more, or
Yes, so quarry dust, stone dust got more CBR value than marble dust.
okay. And what would have been the sand content in both the soils?
Sir, I'm not getting.
What would,
So soil, I was selected that marine clay, which consists of more that silicon
so
dioxide,
what's the
and
fine
sir,
content?
huh?
What is the fine content of the soil?
Uh, which content?
Percentage finer than
Okay.
70.
Percentage finer. Okay. that is my sand and silt particle is 98 percentage.
Okay, so you do not have more of the fine particles. Rather, you have the sand only. And hello.
Yes, sir.
And in that case, mostly you have got the say quarry dust as well as you have got the other dust is
Marble
sorry
dust.
marble. So in case of quarry dust, you have got the better result, I guess.
Yes. That's what I surprised.
Because it is because
Because
it is
maybe.
means what I am just guessing rather from whatever data that has been available to me from your side is
Okay.
because the query dust is finer particles.
Uh,
Okay, and
yes.
it would be means filling the more number of pores than the marble dust.
Okay.
Okay, that is
Okay.
may be a prime reason that you could have for this particular results.
Okay, sir. And somewhere I read, I want to confirm that with you. Based on the that silt content, we have to decide whether we have to go for cement or lime. Suppose in case any cohesive soil like a marine clay, when we have to use the cement, when we have to use the lime. What's the suitability of these two?
Okay. So that is basically chemical stabilization, and
Hmm.
in that, what we have to do is we have to also see the chemical composition of the soil.
Hmm.
Okay, so for example, I have got the sulfur in the
Hmm.
soil.
Hmm.
Okay, then mostly the cements are not so good in cohesion with the sulfurs. Okay,
Okay.
so accordingly, I think you should go for your chemical compositions.
Okay,
So
sir.
basically, you have to see the chemical properties of the soil.
Okay.
Uh,
Yes. I did my chemical analysis, XRF test. It consists of more silicon dioxide.
okay, thank you, ma'am.
Okay, ma'am.
Okay,
Thank
sir,
you.
we
Thank you.
have one more question. Uh, what is the best software for highway design?
Sorry, I'm not the person from